When finding real roots of a function, it is all dependent on the index. So over here on the left, we have a diagram of a root. The index is the little n. So what that index tells us is what type of root we're going to be taking. Now in a square root, we never see a value here. So a square root, it's always assumed that the index is 2, it's just not visible. But as that root changes, you're going to start to see numbers appear. So you could take third roots, fourth roots, fifth roots, really any type of root. And whatever the index is, that's what the number is going to represent. The radical is the root sign. And underneath of the radical, we have something called our radicand. So in our table, we have a couple different types of cases. And we are only talking about real roots, so we can no longer have any type of imaginary numbers. So when I have an odd index, so 3, 5, 7, and so on, you are only going to have one real root. And that's because I can take a root of a negative number as long as the index is odd. When I have an even index, so 2, 4, 6, 8, and so on, and it's a positive radicand, I have two real solutions. So I'm going to have the positive of the value as well as the negative of the value. Now if I would have that same even index, but it's a negative radicand, so it would have no real roots. So in the past, these are the ones that I would have to incorporate my I when I take a square root. We're no longer going to incorporate that I because we want only real numbers. And then our last case here is when my radicand is 0. So any root of 0 is 0. So it's one real root of 0. So we're going to use these properties to fill in the following examples. So in A, it says the third root of negative 27. So that would be an index of 3, and underneath my radical, I would have a negative 27. So I'm going to put this into the calculator and see what value that I would get. In my calculator, to put in the third root, I'm going to hit the control key and then the exponent button. I'm going to put the 3 in for the index, and then underneath the radical, I'm going to put in a negative 27. I'm going to hit enter, and I get that the third root of negative 27 is going to be a negative 3. In letter B, I have the fourth root of 625. So my index here would be 4. Underneath of my radical, I'm going to put in 625. Now I can put this into the calculator and see what value I get. Like our third root, to bring up a fourth root, I would have to hit control and my exponent key. I'm going to put a 4 in for the index and a 625 underneath of the radical. And I get a value of 5. So now I did have an even index with a positive radicand. So if I look up at my table, that means I'm going to have two real solutions. So this isn't just a 5, this is a positive 5 and a negative 5. And then in letter C, I have the square root of a negative 81. So that would be my regular square root sign. I do not have to put the 2 unless you want to for the index, and my negative 81 is going to go underneath. So I'm going to go into the calculator and put this in. Since it is a square root, I can use the control x squared key just to bring up my square root, and I can type in a negative 81. This time when I hit error, it says a non-real calculation. Well, the reason I got that is if I look up in the table, it says even index, but a negative radicand has 0 real roots. So this answer, there are actually no real roots for the square root of a negative 81.